Okay, so on Friday, we considered sentences like every park allows dogs, or no park allows dogs, or at least one park allows dogs. I know in the slides I had beach, but I only have pictures of park, so I'm just going to use the word park here. And we considered pictures to represent the various scenarios. And we explored all of the scenarios and the sentences, and we came up with that square of opposition. And what I want to do now in this screencast is to go over that material again and show you a bit more graphically how contraries and subcontraries and opposites look. So the first place I want to start here is by reminding you the setup. So we had three parks: Hello Kitty Park, Sesame Street Park. This is from a Sesame Street coloring book, and I don't know, Kyoto, a park in Kyoto. And we said, okay, with respect to dog allowing, they couldn't each allow dogs or not. So if they allow a dog, we had a dog here, and if they didn't, we put a big red X through it, which you'll see in a moment. So this picture right here represents a situation when each of them allow dogs. And so that's one kind of situation. And I said, in addition to this one, there are 8 more. And so I want to go over what those 8 would look like. Well, in addition to this case where they all allow dogs, first let's consider cases where 2 of them do and 1 of them doesn't. So that would look something like this. Oops, I went a little bit too far. So in this way the world could be, Hello Kitty and Sesame Street allow dogs, and Kyoto does not. But there are 3 of these, right? So Kyoto could not allow dogs, or Sesame Street could not allow dogs, or Hello Kitty couldn't. So that would correspond to where the X moves, from here to here to here. So there are 3 of these. And then in addition to 1 not allowing, it could be that 2 don't allow and only 1 does. And so that would look something like this. So now only Hello Kitty does. And again, there are 3 of these. So it could be Hello Kitty, it could be that allows, it could be Sesame Street, or it could be Kyoto. Okay, so there are 3 of these. And then finally, it could be that none of them do. Okay, so we saw 1 at the beginning when all do, then 3, then 3, then 1. So that's 8 total. And if we want to collect those all on one screen, it would look like something on the following slide. So I'm going to get rid of the parks themselves. You just have to remember the first one is Hello Kitty, the second one is Sesame Street, and the third one is Kyoto. It really doesn't matter. We just want to keep that in mind while we're talking. But here are all of the 8 possibilities put together. Yeah, so this is one where each of them does. This is one where Hello Kitty and Sesame Street do. Here now only Hello Kitty does, and now here none of them do. Okay, so now how am I going to relate these to the sentences? Well, the idea is the sentences give us truth conditions, and the truth conditions are true in some of these situations and not in others. So in some of these possible worlds and some other possible worlds, they're not true. So what would it look like? Well, let's start with no park allows dogs. So that's going to look something like this. So now what I'm going to do is circle the cases that make that sentence true. So this is one that makes no park allows dogs true. Okay, well, let's go up to the top, and we can do every now. Okay, that's not very imaginative, but let's start with that. So every park allows dogs is true only in this case. It's not true in any of the others. So we have this sort of vast middle now to talk about. Well, what could we circle? In principle, we could circle lots of things. So for instance, the sentence only the Hello Kitty Park and Sesame Street allow dogs, well, that one is only true in this situation. And the sentence the Hello Kitty Park and Sesame Street both allow dogs is true in this guy and this, so these 2 together. But we're not interested in all of the possible sentences we could use to describe this situation. We're really only interested in 4. And so those 4 are the every sentence, the no sentence, and the sentence at least one park allows dogs and at least one park doesn't allow dogs. So let's do at least one park allows dogs. What would that look like? Well, what are the cases where at least one park allows dogs? Excuse me for a moment. So this is one, this is one, this is one, this is one, this is one. In fact, the only one that doesn't is no here. So I'm just going to stretch this all the way over here like that and change that to say one allow. Excuse me, my son is up late and he wants to say goodnight. Okay, so that's one allow. Now, what about one not allow? Well, before I do that, let's just think about it. The only case that doesn't make that true is this. That's what we had seen on Friday. The only situation in which at least one park doesn't allow dogs is this one where all of them do. So I will just drag this guy over here like that, and I'll change that to one not allow. Okay, so now this is how all of these are arranged. And now I want to talk about the various subcontraries, contraries, etc. So in the following slides, I've already sort of marked some of these out, and the figures are going to sort of move a little bit because I don't remember how I drew them when I'm drawing them right now. But you'll get the basic picture. Okay, so the first thing I want to do is to talk about every and no. Oh, well that's that picture. Okay, so that's what it would look like as I drew it. Okay, so the first thing I want to do is talk about every and no. So looking at these two, what can I say? Well, it should be clear that they can't be true at the same time. So, you want to look inside to say the sentence is true in these situations. So every is true only in this one, and no is only true in this one. So they clearly can't be true at the same time. What about false? Well, to be false, you just have to be outside of the box, the set in question. And so, any one of these six situations is outside of every and outside of no. So it's really easy for these two things to be false at the same time, and it's impossible for them to be true because these two sets, they don't overlap at all. We say intersect. They don't intersect. Okay, so that's what I call the contrary, right? They can't be true at the same time. They don't intersect, but they can be false at the same time. Okay. Now let's consider one allow and one not allow. So what can we say about these guys? Can they be true at the same time? Well, to see if that's the case, we ask, do the two sets intersect? And they do on these 6 places. So these two things can easily be true at the same time. But now can they be false at the same time? So to do that, we have to play this game. Okay, so let's look at the cases where one not allow is false. So what is outside one not allow? It might be hard to see, but it's this guy right here. And now for this to be false with respect to one allow, this guy had better be outside one allow. But it isn't, it's inside. Similarly, if I look for the case where one allow is false, that's this guy out here, down at the bottom. But this one is still in one not allow. So it's really easy to get inside both sets, but it's not possible to get in neither like we could with every and no, right? We could easily find spots where we weren't in either set, but that's not the case for one allow and one not allow. And that's what a subcontrary is. They can be true at the same time, but they can't be false at the same time. In set theory, we would say that these two sets form a cover, so they cover all of these things. They have a huge intersection, but they end up covering because of these two additional situations that we're talking about. Okay, so that's contrary and subcontrary. Contraries look like this. There's a vast gulf between them. They don't touch. Subcontraries touch, they overlap, and they together, their union covers everything. So there's nothing outside of either of them, whereas in this case there's lots outside either. Okay, so now let's talk about some opposites. So I'm going to talk crucially about every and one not allow, which we determined were opposites. So the sentences excuse me, every beach allows dogs and at least one beach doesn't allow dogs are opposites of each other. So what does that look like graphically? Well, for things to be opposites, they can't be true at the same time. So that means they can't overlap. They can't intersect. But they can't be false at the same time. So just like what we saw with the subcontraries, if you aren't in one, you're in the other, and vice versa. And that's what we see here. So if you aren't in the every set, you're in the one not allowed set, and vice versa. So see, they partition things pretty nicely. I mean, it's not equal, but they end up partitioning the whole set into two chunks. Okay, what am I showing you in this picture? So I'm not going to show you no and one allow, but instead I want to show you entailment now. So remember, I also said that the every sentence entails the one allows sentence. So every park allows dogs entails at least one park allows dogs. What does that look like graphically? Well, it looks exactly like hyponymy, right? So it's the subset, the more specific thing, is inside the superset, the hypernym, the less specific thing. And that's indeed what we see here. The every set is inside the one allow set. So that's everything right there, right? I'll just go through it once more. I mean, you can obviously rewind and look. So this is a contrary, so they don't intersect at all. There's a vast gulf between them. So that's crucial. I mean, not intersecting at all, but having no gulf is a sign of opposites. The fact that you have this thing where they can both be false at the same time is crucially what makes them contraries and not good opposites. These are subcontraries, they intersect, but unlike, say, entailment, there is stuff in one that isn't in the other, and vice versa. Crucially, for subcontraries, since they can't be false at the same time, there's nothing that is outside the two put together. There's nothing not in their union. These two cover the entire domain. And finally, these are opposites. So, we could make the every box bigger so that it looks like a nice square, but you get the picture, right? If you're in one, you're not in the other, and vice versa. And entailment. I mean, this is a picture you saw with hyponym, and you got it. And so that's all entailment is. That's why I introduced hyponym. I'm not interested in hyponyms. You know what they are. I don't need to give you the word. I just need to say, hey, look, there's something you can bootstrap from. And in this case, it's just the subset, that is the entailer, the thing that's more specific, is inside the thing that's less specific, the entailed. So every entails one allow.